So, my dear students, welcome back. I was doing numericals. So, I have already done two numericals. Now, let us proceed to numerical number three. Numerical number three says astronaut land on another planet and measure the density of atmosphere on the planet surface. They measure the mass of 500 conical flask plus topper. After removing the air, the mass of is so this much, and what is the best estimate of the density of the air. Now, there is another planet, not the Earth. At Earth, what we observe is W is equal to mg. W is equal to mg, and if you are at the Moon, now mass is equal to W upon g, and on Earth g is 9.8 or approximately taken as 10 meter per second square. Okay, but on Moon it is very less. Okay, so
Eventually, the weight is very low over there.
almost 1/6 of the what it is on the Earth. Okay, now this is the another planet. What the planet? The planet name is not okay. Now there is a conical flask. This is a conical flask. It is like this. This is a conical flask and its volume is given. The measure of mass of 500 centimeter, 500 cc, okay, or cubic centimeter. Cubic centimeter in your book it is like written like this, okay. Both are same. Conical flask plus stopper as 500. Now there is a stop. There is also a stopper uh, in this. Now the mass of both the things, the conical flask and the mass of this stopper is how much? It is 457.23 grams. Now weight, mass, it is in fact it is mass, not weight. Mass is equal to 457.23 grams. 0.23 grams, whereas the volume is equal to 500 centimeter cube. Now units are same, we are lucky. Units are same, we are lucky. After removing the air, the mass is equal to, no, there was air captured in this conical flask. Okay, the air was captured, and for some experiment, the air was filled in this from the Earth. Okay, from the Earth, and it was taken to another planet. And now, if the stopper is removed, When the stopper is removed, after removing, the mass is equal to, now mass. This is mass one. When the air is in captured inside, so, and the mass two when air has escaped without air. This is with air. Okay, this is with air. This is with air. This is without air. So it has become is equal to how much? It has become 456.43. 456 point how much? 43 grams. 43 grams. Okay. Now you can see that air has some mass. Air has some mass because when the air was filled in the conical flask, the mass was this. When the air escaped, the mass was this. Now, what is asked? What is the best estimate of density of the air? Now we want to find the density of air. And you know what is density? B is equal to mass per unit volume. I always tell you the definition of the density. Density is mass per unit volume. Now we have not yet calculated the mass of the air. We have not yet we have to calculate the density of air. Density of air is equal to this question mark. Okay. Now we have to find the density of air which is unknown to us. So what will we do? We'll first find the mass of the air. We'll first find the mass of the air, and the mass of the air V equal to M2, mass of air. Mass of air is equal to M2 minus M1 minus M2, sorry, M1 minus M2, because M1 is heavier, M1 minus M2. Okay, M1 minus M2. Okay, now it will become 457. Just forget these because both are in grams. 23 minus 457.43. 457.43. Okay, now these both are in grams, so just don't bother to write the grams again and again. Now we'll just subtract. Now this is the sign for subtraction. Minus, this is minus. Okay, this is minus. Now let me do the step. 457.23 minus 456. 456.43 equals, now this is equal to 0.8. The mass is equal to 0.8 grams. Okay. Now this is equal to 0.8. Now this is not asked. Mass was not asked. Okay. Understood? What was asked is the density. And to find the density, we have to calculate the mass. We had to calculate the mass. So we have calculated the mass. We know the volume. Where was the volume? Since the capacity of the conical flask was 500 cc, and it is assumed that the air filled to its brim was 500 cc. Okay, 500 cc. Now where is the mass? This is the mass, here is the volume. So what will we do here is, we'll simply do 0.8 grams divided by 500 centimeter cube. Now there is a twist in the question. There is a twist in the question. If it was there, it would have been very easy. This would have been very easy, and the answer would have been, the answer would have been 0.8 divided by 500 is equal to this and this and this. This would have been 0.0016 grams per centimeter cube. Now this is not asked. This is not asked because there are four options given: A, B, C and D. My dear students, all options are in kg per meter cube. Kg per meter cube. Kg per meter cube. Now what we have here is in grams. We have here in centimeters or centimeter cubes. So we have to change all the units. We have to change all the units. Now we have to change grams into kilograms and centimeters into meter cubes. It is very easy. I told you in this first lecture of the physics that how to change these things. Okay, now I hope you would have written this. So I am going to erase this. Now there are two things. You can directly change this into kilograms per kilometer, kilograms per meter square or meter cube, or you can individually change. Now To change it individually, it is very easy. Okay, point 0.8. It is 0.8 grams. And from grams, when you go from grams to kilograms, you have to divide it. You have to divide it with 1000, because there are how many grams in 1 kilogram? There are 1000 grams in 1 kilogram. And if you want to reverse the process, if you want to go from grams to kilograms, you have to divide it. Okay, you have to divide it. Or if you want to kilograms to grams, you have to multiply it. Okay, from lower to higher you divide, from higher to lower you multiply. Okay, now back to our question. Now what will happen over here? You see that there is a point, so add 10 and remove this point over from here, and this gram from here. Okay, now this is 0.0001. Now this will become 0.00008 kilograms. Okay, solve 0.0008 kilograms. And what about 500? Yes, 500. Now this is centimeter cube. This is centimeter cube, and the answer is given in meters cube. Is in meters cube. So you see, what we did here was only one dimensional. Only one dimensional. Straight. The gram was converted into kilograms. But here you see that there are 3 centimeters. For to find the volume, what we do? There are 3. Now this is 3 centimeters. There are 3 centimeters. So what we do here is centimeter to meter. We will divide centimeter with 100, because there are how many? 100 centimeter in 1 meter. There are 100 centimeter in, but we have 3 centimeter. So we do keep on divided it with 300. 100, 200 and 300. Okay. When we bring this up over here, it will be 2 zeros for this, 2 zeros for this, 2 zeros for this. Okay. Because all are being multiplied together. All are being multiplied together. So this 0 goes with this 0 goes with this, and what is left behind is 5 comes over here, and it will become 0.000. It is meters cube now. It is meters cube now. Okay. Now let us manipulate. Now. Now this was the grams. 0.0008 kilograms. Now this is kilograms divided by 0.0005 meters cube. Now this will become, now my dear students, now this fraction will become 1.6 kilograms per meter cube. 1.6 kilograms per meter cube. And what we have the options? We have 4 options: A, no; B, no; C, A, B, no; C, no; yes, D. There is a D option, which is this one. So your answer be D. Your answer be D, not this. Whenever you want to multiple choice question, now this is a multiple choice question, you don't write the answer. This is your answer, but your choice is this. You always write the choice. Don't write the answer. This is your answer. Okay, you have done it right, correct. But your choice is this. Okay, you always encircle your choice, not your answer. Okay, encircle your choice, not the answer. There are 4 multiple There are four choices: A, B, C, D. Tuck, 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 tuck. Okay. Do not never do this. This is your answer. This is your answer. Do not encircle this, but only encircle your choice. Okay. Now let me proceed to your next question, which is 4. Question number, the last one was question number 3, now question number 4. And numericals of first questions are underway. Y-axis, x-axis, x-axis, y-axis, and what is given here? This is mass, M-A-S-S, mass, and this is volume, I think. Yes, this is volume. Okay. Now there are 4 things given. Now let me take another marker. Color for another marker is this one. Now what we do here is 1, 2, 3, 4. Let me make the grid first. Okay, let me make the grid from here to here, from here to here. Okay, it is only 2 from here to here and from here to here. Okay, let me make the grid. Tick, 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 tick. Now this is the grid, and 3 products are given. Similar objects. Now this is 1, this is 2, this is 4, this is 3, yes, this is 3, and this is 4. Okay, but 4 objects are given. Now you just understand that these are not the coordinates of these objects. Some students just confuse that these are the coordinates. These are not the coordinates. Okay, these are the objects. Number 1 object, number 2 object, number 3 object, number 4 object. The coordinates are, now for example, this is 0. For example, maybe this is 1, this is 2. And when this is 0, this is 1, this is 2. Okay, suppose that now these are not given to you. 1, 2, 1, 2 are not given. This I have just, for your ease and comfort, I have done it. And to let you understand that these are not the coordinates. These are not the coordinates. These are the uh, objects. 1, 2, 3, 4. Now what is asked over here? The graph shows the mass and volume. Okay. Which 2 objects have the same density? Which 2 objects? 1 or 2? 2 or 3? 3 or 4? Or 4 or 1? Yes, this is the multiple choice question again. Multiple choice question is A 2 and 3 1, B 1 and 4 2, C and 3 4. Okay. Now for density, again the density mass per unit volume. Now the density D1. Let us find the density D1. Now this is D1. D1 is how much? Mass first. Mass is 2. Mass is 2 over here. 1, 2, and density volume is 1, so density is 2. Forget about the units. Okay, because the units are same in all the project. Now D2, just mark this with you. D2, D2, here it is D2. So it is 2 again here and 2 again here. 2 divided by 2, it is 2. 2 divided by 2 is 2? No, it is 1. It is 1. Okay. D3. D3 is equal to, where is 3? Yes, this is 3. This is 1 divided by 1. This is 1 divided by 1. It is 1 again. And D4, let me find the D4. Mass is, where it is mass? D4. D4. This is 1. Mass is 1. And volume is 2. It is half. Now you see, that D2 and D3 are have the same D2 and D2 and D3 D2 and D3 have the same density. D2 and D3 have the same density. So D2 and D3. The option will be what we will select is A, because in A 2 and 3 is given. 2 and 3 is given. Okay, the option is A, 2 and 3. 2 and 3 we have practically done it. Theoretically we have done it. Okay, 2 and 3 is 1, it is 1. Okay, now about next question. Question number 5. Question number 5 is a student measure the circumference of a circular pipe. He wraps the length of string 4 times. I've done this in mathematics as well. I've done this question in mathematics as well, but there it was not the density, it was the circumference. Okay, number 5. He wraps the length of a string 4 times around the pipe and marks in the shoal. So there's a 1, 2, 3, 4. How many times? 4 times. Okay, we have done it 4 times. Now this is the rope over here, and this is the rope over here. Okay, now this is a rough sketch. A student measured the circumference of the circular pipe. He has also measured the circumference, which is equal to circumference. What is circumference? The perimeter of the circle. The perimeter of the circle is called circumference. So it is circumference is 2 pi r. Okay, just take it as 2 pi r or pi d. It is equal. Both are equal. Pi d or pi 2 pi r. He wraps the length of 4 times around the pipe and marks with the ink. Okay, he marked with the ink. No, what is? He has marked here, somewhere here. Okay, not here. He has marked at same place at here. Okay. Now let us turn the page. Video. I mean video. Please turn over. Number A. The student unwraps the string and holds it against a ruler with a centimeter scale. The photograph shows the first 2 ink marks on the string. Use the photograph to estimate the circumference of the pipe. Now, my dear students, another photograph is given to you on next page, which is number 16, and question is A. Now, an inch tape, a measuring tape is opened over here, and it is starting from 170. It is starting from 170 and it lasts about 280, and there are several divisions all over here. Okay, and the ink mark comes at 173. The ink mark, this ink mark, first ink mark comes over here, and the second of the final ink mark, comes over 262.5, something like that. This is 260 over here and some divisions over here. Okay, this is 270, 280. Okay, now the last mark is coming over here. This is the string. Now we have to estimate, because our least count here is 1 millimeter, so we'll estimate it to nearest 1 millimeter. Okay, now this is 173, this is 263. 263, 173. Okay, just minus it. 90 millimeter. It becomes 90 millimeter. Okay, use the photograph to estimate the circumference. the student finds that total length of string is for 4 turn is 354. Now, now my dear friends, there was a little mix up over here. So these two link marks are the first two, as I earlier said somewhere. First two, okay. Now this mark is 1, this mark is 2, okay. Just remember this. I am once told that this is this. No, this is not this. This is over here. This one. So he unfolds all the four. He unfolds all the four and then he measures again it. And he then again measures. So it becomes 354 mm. So it becomes 354 mm. So what calculate the average mean. So when these are 4, just divide here. And if you want to find the mean of anything, this is the total number divided by the number. Okay, the measure of the number is equal to, now this is your total measurement divided by 4, because these are the 4 terms over here. So 354 divided by 4 becomes 88.5 mm. Now this is the mean. You see, it almost resembles to what I did it for the first two marks. I already told you that it is somewhere between the 2 marks, but I am going to take it because the least count here was 1. So I took it for 1 millimeter. So it is almost the same. And since it is mean, so it will become 88.5 millimeter. Now question number 6. Suggest how would you work out the thickness of single sheet of paper if only measure device available to with ruler with the smaller division 1 millimeter. So this is a very much question which now you have only one paper, only one paper, okay, and you have a measuring ruler. Okay, you have only one page and ruler, and you want to know the thickness of that page. Okay, it is not very much difficult, but you have to spoil the page because you have to fold it to many folds. You have to fold it to many folds. Then you will be able to know that. Now, for example, you have this page. Now this page, you know, the thickness cannot be measured with this. The thickness cannot be measured with this. It is very thin. So you will fold it like this. First fold. Now there are two sheets. Now there are two equal sheets. Just give a squeeze over here. Make a crease. Then make it double again. You see, 1, 2, 3, 4. Now again 1, 2, 3, 4, 5, 6, 8. 8 folds. 8 folds. Okay. 8 folds. Then 8, 10, and again. Okay, I cannot make it. Now there are 10 folds. Now I can measure it. Now I can measure it with this. Okay, this has come almost equal to 1.25 millimeter. It has all come. So what are the 10? So 10 divided with 10 folds. So you will find the answer. Okay, 6 done. Okay, question number 7. Question number 7 is a glass slide is given to you, and a glass slide measures. Now measure is 75 mm multiplied 26 mm multiplied 1 mm. Okay, now this is a broken volume. You can say it. This is a broken volume, bifurcated volume, because this is length, this is breadth, and this is thickness. Okay. Now other thing is given to you is density. that is 2.24. What are the units? Grams per centimeter. Grams per centimeter cube. Now you see, my dear student, the units are changed over here. These are centimeter cube. This is millimeter. Millimeter, millimeter, millimeter. Either you just multiply all these as they are given. Multiply these all as they are given and then divide it. What will come? The volume will come. Just volume in millimeter will come. Millimeter cube will come. Just divide it with 1000. Okay, because millimeter, there are 3 millimeters. Or you can just separately divide the individuals with 10. You can divide the individual with 10, and if you divide the individual with 10, it will become 7.5 cm. Now this is cm, this will become 2.6 cm, and this will become zero point 0.1 cm centimeter. You can do it either like this or like this. For example, I do it like this. Okay. For example, I do it like this. It will become 75 multiplied 26. It will become 1950. Okay. Now this is millimeter, millimeter, millimeter. It is millimeter cube. This is millimeter cube. So we have to change it into centimeter cube. So centimeter cube, for each there are 10. Okay. For 3 there will be 1000. So it will become, for this, for this, for this, and it will become 1.9 centimeter cube. Or if you go it like this, again it should come like this. 7.5, 7.5 multiplied by 2.5 multiplied by zero point 0.1. Yes, it has come 1.95. Okay. So 1.95. Here it was also 1.95. Here it is also 1.95. 9 is also because 5 is also there. So we have find the volume. So we have find the volume 1.95 and density is also given. So D is equal to, now D is equal to, so D is equal to mass per unit volume. So what we have to find is mass. So when we have to find the mass, we'll just multiply it like this: D multiplied by V. D multiplied by V. Okay. Now mass is equal to D multiplied by V, where mass D first D is coming. So D is 2.24 grams per centimeter cube, and multiplied by volume. Volume was 1.95 centimeter cube. Okay. Now you see that this centimeter is uh, in the numerator and this is in the denominator. So both will cancel and the numerical values will be multiplied. The numerical values will be multiplied. See, this is in denominator per centimeter. Okay. Now 2.24 multiplied by 1.95 is equal to 4.368 grams. Only this unit was left over here. So 4.368 gram is the mass of this last slide, which measures this. Okay. So question number 7, 8, 9, 10. Let me see. 4 different materials are poured into this. Calculate the volumes in the table. So it is very easy. Just manipulate the formula and you'll know it. Okay. Metals are denser than water. Explain why ship can float. Okay. Now this is a very common question, and in olden days it was also asked in the it was also asked in the interviews. So, my dear students, it is very easy question, and the principle or buoyancy or the Archimedes principle is the answer, because when you put anything, this is a tub filled with water. If you put anything in the water, for example, this block or this sphere, whatsoever, any object, now when it will go down, it an equal and opposite reaction will occur. An equal and opposite reaction will occur to push it back. To push it back. Okay. Now this is called the buoyancy. Buoyancy. This is called buoyancy, and the hull of the ship is so designed. This is the hull of the ship. This is so designed that it just displaces the water such that, uh, according to the Archimedes principle, it displaces the equal amount of water. Equal amount of water. So the sea is very large, so it does not feel anything, and the ship flows on. The exact is the principle of buoyancy and the Archimedes principle. The matter is denser than water. The ship design helps is to displace the water, large amount of water, then the ship is placed in the water. So it just displays a large amount of water when it is put in the water, when it is launched in the water. So it does not make any difference to the water or even to the ship. So it floats it on the water. Okay. And I told you about the principle of buoyancy. Buoyancy is that an equal and opposite force reacts upon it to just push it back. Okay. Now question number. This was the simple, and you can write it. Suggest how could work carrier density of the drying pin. Okay, drying pin. The density of a drying pin. What is a drying pin? There are some sort of pins. Now, in my opinion, the drying pin, what is it? There is a paper pin or common pin. Now, this is a paper pin to tie up the two papers. This is a stapler pin, okay, to staple the papers. And this is a drying pin or thumbtack. It is also called thumbtack. Thumbtack or drying pin. Thumbtack. Be silent over. Thumbtack. Okay. Now it is used to put notice on the notice board. Notice on the notice board, or to just paste the sheet on the drawing board. Okay, just paste the drawing sheet on the drawing board. It is used, and there is also other like shoe tack. Shoe tack is like this. This is a shoe tack. So we are considered only with the thumb tack or drawing pin. So it is very much not very much easy. So we have to find the density of the drawing pin. Now there is a simple method of level water level rise. Water level rise. What is the water level rise? This is the graduated standard. You just find the mass of the pin and put it into the water and just note the rise. But my students, what will happen? That this drying pin will not show you this much displacement in the water. The single drying pin will not show you the. So what will you do? You will take some 50 or 100 pins like this. Then just uh, take the mass of 100 pins and then put all the 100 pins in the water, so it will rise. Then divide by the 100, you will find them. Or in other, you just measure this, and there are a lot of methods. Okay, By measuring these, you will know the volume and the mass. You can take it on the very precise measuring scale which jewelers have. So we don't have the jewelers scale. Maybe in kitchen we do have some scale, but these are not very precise. This can only go up to down up to 1 grams only. Or you can say the least count of the kitchen balance is 1 gram. Okay, so it is very much difficult to find, but the, the method I told you, take a bundle of pins or puri pack of pins, just pack a pin, then weight it on the kitchen scale. Okay, you'll know the kitchen scale. Then put the whole bunch of the pins into the water, and then just note the rise, deduct the rise from the previous one. You'll know the volume, then divide uh, the volume with 100. You'll know the, okay, you will know the volume of one pin. Okay, now this was, okay my dear students, the end of chapter number 1, end of chapter number 1. And in chapter number 1, what we learned is length and volume, length, volume, and density, and last we measure the time. So time is finished.
Time to say you goodbye. Allah Hafiz. See you next time in our next video. Allah Hafiz. Take care.